Hello, my name is Riley Pointer, and this is my presentation for Physics Lab 1, Constant Velocity. The purpose of this lab was to observe and analyze an object moving at a constant speed in a straight line, therefore demonstrating constant velocity. For this experiment, I used a yellow Almost Golf practice golf ball rolled across the floor of the physics lab in Clough Undergraduate Learning Center, room 382. This experiment modeled Newton's second law, momentum, which states that an object stays in motion unless acted upon by an outside force, or that it stays at rest unless acted upon by an outside force. It also modeled Newton's third law, where every action has an equal and opposite reaction, that being the force the ball exerted back on my hand when I rolled it. So I chose these conditions, a golf ball and the floor, for three reasons. First, the size of the golf ball made it easier for me to exert a noticeable force on it. Second, the shape of the golf ball made it easier for it to maintain momentum. And third, the flat surface of the lab floor minimized friction and other external forces, ensuring a near constant velocity. After I recorded the ball's motion using my phone, I then opened the video in the tracker program, which allowed me to gather the exact position of the ball at several timestamps. This data was then used to create a graph in Excel, which is modeled by the orange line on this graph. As you can see, the line is almost perfectly linear, which indicates that the ball maintained near constant velocity and direction throughout the recording. In addition to the observed data, I also used it to generate a line of best fit, which is shown by the blue line on the graph. This represents the predicted position over time. As you can see, the predicted and observed results align closely, though the predicted line is perfectly linear by design, while the observed line has slight deviations. There were a few potential sources of error in this experiment. First, the floor might have had small imperfections, including minor obstacles that affected the ball's motion. Additionally, the force I applied when rolling the ball may not have been perfectly consistent. This could have introduced various adjustments in the ball's motion, such as curving. So, one of the questions in this lab was, what if the axis was flipped when using the tracker program? If I were to flip the axes from positive x to negative x, I believe the results would remain essentially the same. Since the motion was linear, flipping the axes would only change the sign of the coordinates, but not the overall outcome. Now, using physics principles like the position update formula and the momentum principle, we can predict the forces acting on the ball at various points in time. By applying these formulas, we can estimate the number of pushes and pulls needed to maintain or stop motion, as well as the net force required. To summarize, this experiment successfully demonstrated constant velocity and Newton's laws in action. The data collected closely aligned with the predicted model, and the sources of error were minor, but should be considered if the experiment would be repeated in the future.